Aditya, do I start it now? Sure.
So,
Um, yeah.
actually, after installation, when I want to check whether it's correctly installed or not, as per the program that you sent, like CV2 version, it is showing that attribute version does not exist or it's not there for CV2 module.
Um, can you like share an image of what you're facing in the chat?
Okay, yeah.
All right. So, hello guys. My name is Jacob. I am a second year electronics student at PS University RR campus. So, I'll be conducting the image processing workshop for leading up to Robofest. So, has anyone here ever done anything in image processing? Like, let's have a quick icebreaker, if you may. Okay, I'll take that as a no. So image
Hello.
process.
Actually, image processing I have done. I have attended a few workshops of Gokul, and also I was there in Project Oasis. So as a part of that, and I have used the OpenCV.
Okay, cool. So yeah, so image processing is basically where you try to get information or like try to process an image For example, like when you have a person standing, you need to detect if it's a person, or if it's a bottle, it's a bottle. Those are like examples of image processing. What we'll be doing today will be just covering the very basics of image processing, like how to input an image, how to get video, how to present the video, how to add text to the video, and in the end, we'll be able to detect colors, like different colors like red, blue, yellow in an image, and draw boxes around them, so we can find out where a particular color is present in a given video feed or image feed. So let's start with the basics. So, what we'll be using today is Python, and we'll be using two libraries mainly, that is Numpy and OpenCV. So NumPy, I'm sure quite a few of you might have come across it in different forms. We'll be using very basic amount of NumPy here just to create arrays. So because we for certain image processing functions, and OpenCV is our fundamental behind the entire image processing. It has a lot of inbuilt functions and in already trained models that help you detect colors and other various other things much more efficient than any other library present, and it's kind of the standard in the image processing field. So yeah, so how to exactly get an image? So I assume all of you have. Okay, so first, I hope all of you have your laptops and editor of your choice open. So we start with importing. So for like we import any library in Python, you type import CV2 to import the OpenCV library, and you import NumPy as NP. So you type import NumPy as NP to import the NumPy library, and it's you can use just NumPy, import NumPy, but since NumPy is a pretty big word, I guess, so people prefer to import NumPy as NP. So once you do that, so first in image processing, what we need to do is actually take the image, right? So for that we have this function called imread. So imread is used to import images. So you can use in the inside the function that's given, inside the parenthesis you have path, right? So in there you put single quotes and put the path of the image that you want to read. So that will help you take the computer, take the image from your memory and use it for your image processing functions. And similarly, if you want to do with video, you have this cap. Cap is just a variable name. Similarly, img also is a variable name. You can use anything there. So cap is equals to cv2 dot video capture. So here n. So n is like sometimes you'll have multiple webcams connected, right? Especially if you are using a desktop, you'll have an external webcam. So if you're using an external webcam, the n is replaced by 1. If you're using a laptop with an inbuilt webcam and you want to access an inbuilt webcam, you use as n as 0. So this will help you get the information from your camera feed, or help you take the image into your code. So now if you need to show your image, so this right now is gonna be, if you run import opens a CV2, and then the image equals img equal to cv2 dot imread of path, let's say any image of your choice, and then cv2 dot imshow of name of window comma img. So this will name of window will be replaced with what name you want your the window screen to show, and img would be the let's say the image. So has anybody tried this? I'll show how it works. One second.
Are you presenting anything?
No, I'm trying. Like, has anybody tried this to get the image output?
No, not yet.
1 second.
Where exactly do we have to run this code?
In any, like, you just like how you run a Python file, right? So you like run it in your terminal, or if you're using VS Code or what PyCharm, you just run it in the inbuilt terminals.
Is it possible in Jupyter?
Jupyter Notebook, yeah, you can run it in Jupyter Notebook too. Like if like just the same way, I guess. If you have downloaded your OpenCV in Jupyter.
Okay.
Um, 1 second, I'll show how it's done. Present my entire screen. Yeah, so here you have the first line, that is import CV2. All right, and here I'm going to tell how to get the webcam image. So here instead of cap is equals to cv2.video capture, I've used webcam equals cv2.video capture. Since I'm using a laptop, I have an inbuilt webcam. So we have this 0 over here. Then there's a while loop. Since we are using the webcam, a video feed is basically a series of images, like multiple images that pass through a fraction of a second. So that makes you feel like it's a video. So we run through a while loop. So this webcam.read function passes two variables. Like it's a function that gives two return variables. So one is your frame, that is the image that has been taken at that particular second or millisecond, and this underscore is a variable that tells you if your webcam's working. So if you want, you can run the remaining of the code in your while loop only if an input feed is available. So this underscore variable is used for such a purpose. So here I've made this just multi-purpose, so you can be like hello here. So, and here our cv2.im show hello of image frame. So image, so it shows this image frame that's been taken in this iteration of the while loop in the frame. And then this remaining is to like for this wait key gives like a delay kind of thing. So you, if you want to like quit like presenting the video, instead of like stopping the Python code, I have given this option. This helps you like get the keyboard input and helps you destroy all window, like webcam.release stops the webcam feed from coming in, and cv2.destroy all windows closes the window that's been created in this line over here in the line 14, and breaks out of the while loop. So I'll show how it works. So we have Python. Got it. So I use VS Code, so I just have the run button over here. So I just use that. So I'll run the code here. So yeah, as you can see, I get the image feed from the webcam, and see, as you can see here, this hello, it indicates the name of the window. So now I press Q and the window is closed. Has anyone faced any issues?
Can you share this code once?
The code, 1 second. I have put it in the chat box. Did anybody get it running? If so, just put a yes in the chat box, I guess. Anybody got it? Yes, thumbs up. Anything? All right, I guess a few people got it. So I hope the others, yeah. All right. So then, yeah. So that is like probably going to be like the beginning level of getting image and presenting, like showing it on your through your code. So now we'll go to a bit of theory, I guess. So yeah. So now we have about shapes. So I won't be running through all these as of now. I'll just show how these functions work. And the end, we will make a small project which will help you detect a color in a frame. So that's where I'll like show how the rest of these functions work. So here we have So here we have first how are colors defined in image processing. So there are the basic one, that's RGB. So RGB stands for the primary colors that are red, green, and blue, and they are basically the colors that are mixed and matched through it to with each other with different intensities that help you get the necessary shade of any color that you prefer. So I'm pretty sure most of you know about RGB and about primary colors. Um, so Anushri, VS Code installation is just the same as your normal through the terminal installation. If you have installed it through the terminal, it should be available in VS Code too, because VS Code is just a code editor, like Notepad. So yeah. So RGB is like for the so when you input any image or like we just did or our video camera feed, it's always in RGB format. But for computational purposes, RGB isn't very efficient because you can't get values like saturation and the hue of a color, etc. So we have something called as HSV. So HSV stands for hues, saturations, and values. So hues are basically the three primary colors, that's red, blue, and yellow, and the three secondary colors that are like orange, green, and violet that appear in the color wheel or color cycle. So when you refer to a hue, you refer to a pure color or the visible spectrum of basic colors that can be seen on a rainbow. So these are colors that are inside a read function. Um, I am read, if you are referring to, it refers to the path of the image. So you can only give the path of the image inside read and it should be in single quotes. So yeah, so back to where we were. So HSV stands for hue saturation. So hues is basically all the colors that you see in the rainbow, like Vibgya. So those are that's what hues is. Saturation is the intensity of the color or purity of the color. Like some yellow seems very bright and very vibrant, while some seems dull. So this is what you mean by saturation. Some maybe you guys have done some form of photo editing in your mobiles, and there are options called saturation that makes some colors seem very like fizzled out, and some seem very bright. So that is what you get by saturation. And value is the relative lightness or darkness of a color. So when you take color value, it's basically the quantity of light that's reflected off that colors to then receive and is perceived by the human eye. So basically the intensity or the brightness of a color is referred to as value. The exact math behind it, we won't go into it here, but that's it's just the basic definition of what is hues, saturations, and values. Some sort of theory, I guess. So so now if you want to convert the an image in like for example, you want to convert it into, let's say, a grayscale image, because in some cases you cannot use your image as it is in RGB format, like I said. So you will have to use it in HSV form or grayscale form. The grayscale form is basically turning your video feed into black and white. I'll show how it works in a second. So basically, in grayscale, or like so. Basically, this convert color function helps you convert the image or the frame in case you're doing video capture to into a grayscale format or into the hue, saturation, and value format. I'll show how it works in a second. So I'll share my PS code in a second. So as you can see here, I've taken image. So image frame is just so here I have converted the image frame that you receive from the webcam in RGB format into grayscale format using this function cv2.color underscore RGB to gray. So this helps in converting your RGB colors into grayscale format. So, but the thing in this case is you can only use image frame in grayscale from now on, since you've converted the original source of RGB. But if you want to keep the original RGB for some other purposes later on and convert, then you can create a variable called img instead of image frame here. So I'll run this and show how it works. So see, you can see that the frame, the video feed that you see right now is in grayscale format. So we can do the same with HSV. So, so yeah, now you see like all this reddish image. That's because of all the hues and colors and saturation, because it's pretty dim right now. So this is how you get the output image. So yeah, back to the presentation. So did anybody face any issues in converting the color? All right. So so now once like you detect something in an image, you have to know that you've detected it for like debugging purposes. We draw an image around it, or a box or a circle around it. For example, if you detect, let's say, a red color in an image, you draw a red box around it, so that when you are testing your code, you can make sure that it works. Let's say you want to make a lane following car. So you have the webcam feed of the two lines on the road, and if you draw the boxes to make sure your code is detecting these lines, no matter where they are, how they are placed, the shapes are, to ensure it fits into your parameters. So, and then you can then continue with your code knowing that till then whatever is there, it's working right. So here so here you have image frame is equals to CV. So the first two lines is basically one single function. So that is to help you create a rectangular box in your frame, and the second line is to create a circle. So in the rectangle, the first parameter in your cv2.rectangle function is the image that you want to pass, and then x1 comma y1, that is the coordinate of the top left corner of your it's the one second. Yeah, so it is the coordinate of the top left corner of your rectangle that, or in your frame that you want it to be placed at, and x2 comma y2 is the bottom right coordinate of your rectangle, and then color underscore RGB refers to the color of the line that you want to be drawn. You can draw it if you want to, if you have a multicolor system, let's say, you can draw boxes around red color in red lines and green in green and so on. And thickness refers to the thickness of the line at which you want to do it. So, and same thing for circle. Here x1 comma y1 refers to the center of the circle that you want to draw, and radius is the radius of the circle, and the other parameters remain the same. So I'll show that in a second if you guys want it. I'll show the screen one second. Yeah, so it's I can see. See, I removed the grayscale one. So here your CB2 rectangle. So image frame is the frame that I want to use. 10, 10 is the coordinate of the top right. 80, 80 is the top left, and 80, 80 is the bottom right, and 0, 0, 255. So this is like the values for colors. So this will be the amount of blue. This will the second parameter in between the parentheses will be for your green, and the third parameter will be for your red. So this ranges from 0 to 255. So if I put 0, 0, 255, that's 0 green, 0 blue, and 255 red. So that means I'll get a red colored box. If I put this as 10 or say 40, it will give me a different color. So I'll show how this works right now. So as you guys can see, there is a red box in the top right corner. So top left corner, sorry. So like if I change this to, let's say, 100, you'll get a different color. I'm not exactly sure color it is, but yeah, you can see it's orangish. I put this also as 100. I'll get it's a shade, I don't know the name, sorry. So like yeah, we can make this 255 if you guys want for it. And put a 0 and 0, I'll get a blue box. Yeah, a blue box, as you can see. So that's for rectangle. So circle would be the same. I would make this circle, put the coordinates of the center as this, and for 80, 80. And this would be, let's say, 5 centimeters, 5 units. So now you can see there's a small blue circle in that point over there.
Excuse me, I'm not able to see any boxes or output which you are going to see.
Yeah, me too. The images are not showing.
Only your VS Code has been shown.
Oh, all right. Wait, I'm sorry.
You aren't able to see anything.
Oh, yeah, I'm presenting the whole screen again. Yeah. So
Could you show the other things also?
yeah, I'll show the rectangle. So can you see the blue circle now?
Yes.
Is it? Yeah, all right. So similarly for the rectangle. So this is for blue in color. Yeah, so you can see the blue box on the top left. So similarly, like I have to close it. So I put, let's say this is also 255. So Here I put B is 255, green is 0, R is 255. That's red. So I'll get a different color. I get pink in this case. So I put all as 255. I think I'll get black. No, I get white. All right. So I put all 0. I get black. Yeah. So yeah, this is how you do rectangle. So circle, you can do the same color stuff. Just you specify the center there and the coordinates. You guys saw the convert color function, or do you want me to show that too again?
Can you show that too, please?
All right. So, I already have it here. So here I'm converting the image frame into HSV format. So if I run this, yeah, you can see the image frame is in HSV form. So this gives you hues and saturations of the instead of the RGB form. So it'll take the color and convert it into the and depict it in the form of the hue and saturations. So if I want to convert it into grayscale, um, I get, yeah, so the entire image is in your usual 1960s movie style. So yeah, everybody got this, or do you want me to share the codes for this too in the chat box?
Yeah.
All right, I'll share.
I have one doubt. Isn't the HSV supposed to make the image look better? The image looks worse. I mean,
Yeah, it's not about looking, it's more like the input you're getting from those different pixels. So in the RGB, you just get the colors, right? Like you get the, is it a red color, is it green, blue, the shade of the color, etc. But in HSV, you get the how light the color is, how bright it is, how much it's saturated, etc. So these are information you take from the image so to process it better. It's not about how it looks better, it's more about how you can process the image better.
okay, thanks.
So wait, so yeah, this is the code for the, I sent the code for the converting the frame colors into gray. You can change GRAY to HSV. So yeah, I'll share for the rectangle too, and you guys can do the same for the circle. Run it and tell me if you have any doubts. If you guys run the code without any issues, just please put a yes or a thumbs up in the chat so that we can move on to the next topics. Okay, I see Shreya's got it, Kanta also got it. If we get around 4 or 5 more responses, we can move on to the next topic. Chaitanya. All right, cool. So that was about drawing boxes. Now it's about putting text in the image. So like sometimes you'll have to write just like how we put boxes. It's You will have to specify if it's a person. Let's say you are creating a detection model, so for multiple different images, so you want to see if it's detecting a person, or it's detecting a bottle, or it's detecting a mobile phone or a mask, whatnot. So for writing text on an image, this is the function. It's called put text. So the first parameter is, as always, going to be your image frame. Then it's the text that you want to add. All right. So, and then you have the font face. That's like the style of font that you want to put on that's the text font style. Font scale is the size of the font, and color is a color, and your thickness, and then you have a lot of other parameters which are not generally used. So we'll deal with these points. Org refers to the center of your, like, considering your text is a three letter phrase. It'll consider a box around it and take the center of that box and place that at the coordinate you specify in org. So let me get that up and running. So x comma y. Let's see. Et comma a. Okay. I'll share my screen now. Is it visible? The
Yes.
VS Code. Yeah, all right. So I'll run it. So the frame is visible, right? So you can see "Hey guys" written over here in text. So I changed the point of the org, let's say, to 180. Yeah, so it shifts a bit. So also, I don't know if I mentioned this. This 180, let's say my frame size is, the window that appears is of the size 540 into 540 pixels cross 540 pixels. So if I specify like 600, it won't really show you an error. It will just try to place the text or image or box outside that specific point. So for example, let's say I put here 1080 and 1080. It won't really show you an error. It'll just look like it's not there, but actually it's trying to put it in that specific pixel on your entire monitor. So this size you must take in mind the size of your frame. There is a function called cv2.resize that helps you define the size of the frame. So let's see if I can show that here. So I have image frame is equals to cv2.resize, comma, say 200, comma 200. Not sure if that's the exact. See, so the window size has become 200 cross 200, and you can't see the text anymore. So yeah, that's a function that we could use. So yeah, I'll just remove it. The default size is usually enough in most cases, unless you are creating some sort of application where you want to make it look good, or you want to like see a better result, like to make the result more obvious. So I'll share this. So yeah, and yeah, so one let's say so 1 comma 0 here is again font scale. So I put here 3 or 4. It will give you a larger font size. So yeah, it'll just go out of frame since the center of the box is what matters. It doesn't consider if your text is going to be staying inside your window or not. And this is again the same uh, same format that we used in the rectangle and circle for the colors. It will give you the same form of like you can change around the play around with the values for the colors you desire. And then this is the font styles. Like you have a lot of font styles options. So yeah, so you can see Hershey complex, small, duplex, Hershey plain, script complex. These are all different forms of font styles that are available. So yeah. So I'll share this code too in the chat box. Slides. Anybody got the output? Just yeah, put the same thumbs up or in the chat box. Two people have got outputs and around like let's again wait for like 4 5 I guess and we can go on again. Is anybody facing any issues? Right, so yeah. So now we'll learn about some NumPy functions. So we'll be using basically these two functions, NumPy arrays and NumPy ones. So NumPy arrays helps in creating a basic data type of an array. That so the it'll keep the if say like you have Python arrays, right? Like in Python. So if you want and create an array of like a constant data type throughout, you use numpy.array. So you create like if you want to create, but you put like float and other different functions into your numpy, it will create like it will take the largest data type and create the all the arrays for like you create an array of that data type. For example, you have float and binary and decimal all in the same array. It will create use you make all the values into float types since that's the largest type of data. Um, so it's a grid of values and it's indexed by a tuple of non-negative integers. So and the number of dimensions is the rank of the array. Like if it's a 2D array, it'll have a rank a 2, a 3D array, etc. And the shape of the array is a given tuple of integers giving the size of the array along each dimension. So when you define by a shape of the array is basically the uh, it's it in each dimension how big is the array. Like if it's a 4 by 3, so the shape in x axis will be 4 and in y will be 3. So that's NumPy and we have then np dot ones. It creates an array of that's just filled with ones. So you have a here I'm showing 5 comma 5. It'll give you a 5 into 5 matrix with just ones in it. So yeah, that's just basic NumPy. NumPy has a lot of applications in a lot of other fields like machine learning and data analysis and all that. So we will not dwell too much into this. We're just covering the two functions we will be using at our project at the end of this course. So now we move on to masking. So a mask image is simply an image where some of the pixel intensity values are zero and the others are non-zero. So for example, you want to get like you have an image like when we saw our when we take a webcam feed and you are doing red color detection, but you want to like pick out the red in an image and show it separately. There we use masking. So we basically take those points in the image which are of our need and consider that as our basic image, and the rest of the image just we convert it into black in color. So wherever the pixel intensity value is zero in the mask image, then the pixel intensity of the resultant value of the image will be converted into the same as that of the background value. The background value is normally here zero. So here the function that we use to create masks in OpenCV is cv2.inRange. So the first parameter, as usual, is the image frame. So and then we have the lower color. So as the color lower basically refers to the pixel range, that the color range which you want to consider as the lower end of your mask. So you want to take red from some certain intensity, or you want to take all the colors that range between white and pink or pink and red. You specify the let's say the lower one, like white we saw was I think 255, 255, 255, and pink has its own value. So we take pink as the lower color and the white as the upper color, and etc. Considering what should be your range. We'll see how this works later on in when we do the project, and like when we do the final example, like a small project, mini project. So now we'll move on to dilation. So dilation is basically it increases the object area by adding pixels to the boundaries. So you have a certain image like a person, or let's say a color of an object, and you want to make it more visible. You you detect that image, detect that portion through your let's say through your machine learning model or through your color detection function or something, and then you add pixels to the boundaries. It helps in accentuating the features of the image, and also increases the foreground object by increasing the white region of the image. So it makes the image that you want to see more visible compared to the rest of the image, so that it can help you make sure that what you want to take out from your image, or what you want to detect in the image, is actually being detected. And like when you dilate out the remaining of your pixels, it helps in processing the image easier, because the rest of the colors in the image won't really affect your processing capability. So the dilate function has three parameters basically. First parameter is your IMG, that is as usual your frame, and next is the kernel. So kernel is basically a matrix that you multiply to your image kinda to so like uh, let's say you want to blur your image. So when you want to blur your image, you try to take a certain size of pixels, let's say a 3 by 3 matrix of pixels on your image, and then you multiply them with the average value of the individual pixel intensity in that matrix. So let's say you take the 181th pixel in the x-axis 182, 183, and downwards on the y-axis you take 80, 81, 82. So you get a matrix, right? So on that matrix, you take the color intensity of each value in that matrix and average it, and then consider that to be the color intensity of all the 9 pixels in your matrix. So kernel is basically a matrix that you would multiply to these pixels. So when you're doing blurring, you don't necessarily need to kernel, but when you're doing dilation, you want to say how much to dilate it. So you will multiply the matrix of the color intensities to how much you want to dilate it with another matrix. And iterations refers to the number of times you want to perform this dilation. So one dilation probably will cause it to dilate by a fraction. So 2 times will make it do it twice or thrice. I'll see if I can get to show it. Alright, I'll present my code in a second. Alright, so as you can see, so I've defined a kernel of a 5 into 5 matrix of integer type. This is just I use np.ones function here, so I just get a 5 into 5 matrix of just ones. So I have used dilate function. So here I pass the image frame and the kernel size. So I will do this. Wait, I have probably iterations is equals to, let's say, 1. So run this code. You can see the image is a bit more blurred out, and like things are not really defined in the image because you're applying a kernel throughout the image, so it's dilating your image. So if I use a mask with this, it will dilate the image part of the, except the mask, whatever is there in my frame, it'll dilate it. So if I do this, let's say 3 times, see what difference it makes. So yeah, you can't, it just looks like a Minecraft character at this point. So yeah, so I can change the kernel size too and show you the differences it would create. So I'll go back to a single iteration. So yeah, you can see the blur is a bit more. We can't really understand the difference between changing kernel sizes and iterations just by this. But when you take a larger kernel size, it would not really create a difference in dilation. But when you do like I talked about blurring and other stuff, it would create its own difference. Also, if you're using like a mask, you will have like very small pockets in the image frame where you don't have red color. Let's say the top, like it's almost filled except for a very small region. But you're trying, like it'll just be a 3 into 3 sized pixel array, but you're passing a 10 into 10. So that would create the dilation, that would not dilate those areas, and it would cause errors in your code detection. So you have to be like, keep searching through trial and error more or less to figure out what is the right kernel sizes. So I'll share this in the chat. 1 second. Any issues until now? Anything you need guys need to get clarified?
I had one doubt. Is the dilation function only used to like blur things or anything else?
Yeah, it's used to blur things basically. It's like it's not exactly blur, it reduces the intensity of the each pixel of those points. So it will like for example, you want to focus out a certain part of your frame using a mask. So when you create a mask, what do? You take out that part of the image, but you want to still combine them together and show. So you would apply the mask back onto the, you'll apply the mask onto the original frame, and you will blur out the rest of the mask that's just not masked. So you can basically focus on your image. Like when you do, like when you take a photograph, you have these portrait modes, right? It's something like that. So it'll help you like focus out your main object that you want to detect.
Okay, thanks.
Somebody else was asking something. Have you guys run the code and tested it? Share the PPT again.
And one more thing, does it matter what numbers are in the array, like the ones or?
No, I'm using np.ones, right? So if you create a specific array of like, let's say like of a 2, 3, 4, 5, it would create its own differences. But here, since we don't really need it because you want all the intensity to reduce by the same factor, you can just use np.ones, which gives you a array filled with ones of your chosen size.
Okay, thanks.
So, anybody else has any doubts in the code or in the theory part? And if you guys ran the code, yeah, just put a yes in the chat. All right, I guess I'll just go ahead. So now we have bitwise operations. So let's say you want to take a common part into image frames, like we talked about mask. So when you create the mask, it takes out the thing from the frame, but it doesn't really get you a whole new frame. So you want to like separate them out, you use something called bitwise operations. So we are going to mainly use two bitwise operations. One is bitwise and the other is bitwise or. So bitwise and does the and function. So it basically takes out the it takes your it takes the two frames that you want to perform the bitwise and function on, and it will take out the and will apply a mask on it. So if you have a mask, let's say, like you want to do the red color masking, you add that mask onto it, or you can do a not just you can ignore the mask function itself. I'll try to show how it works in a second. So I'll just yes. Don't get some just 1 second. Take me a second. One second. All right. So I just so yeah. One second. Share my entire screen. Oh yeah. So here I've taken two images. So one is this, it's just a one side white, one side black, and the other is black with a white circle in the middle. So when I take input and it will give me a image like this. So it'll basically take what's common in this side. So what's common in the left half of our image. This white part is not common anywhere except in this middle semicircle. And on the right side, since this thing is whole black, it will take this entire thing as black and then just so it basically do a AND operation. So AND is basically, let's say, multiplication, right? So here you have white and white and black. So except for this half circle, everywhere else, as you multiply black into white, you get black. So like let's say black is 0 and white is 1. So when you multiply them, you get 0 except in the common region. Common region is only available in this left half and only in the semicircle. So now, so this is the code I have used here. Um, let's so here see, as you can see here, there's no mask applied in this case. If I input one image, input two image, as you can see is here. If for you guys to use this, you will have just I'll send this code and the images. Try place the images in the same folder as you have this Python script running in, and I'll also show OR operation. One second. So, close the previous window. Yeah. So OR operation is basically like say addition. So here you have in the left half you have black and white. So you add them, you just get white everywhere. And then on the right side, you just until this as this white circle everywhere you get a white image. The rest of it, as it's black and black, you add them both, you just get black. So it's just like a normal and condition. It's just you're applying it to pixels. So if you have, this is just a very basic representation of it. When you have other colors like red, blue, you get different kind of outputs depending. And if you apply a mask, others, so on. So I'll share this code. If has this anybody have any queries regarding that?
Can you show it with the mask on?
It's because I'll have to apply a mask. For that I need to create one. So I'll show that when we do it in the final presentation. Is it fine like that?
Yeah, no problem.
Or I'll try to share the files now. I don't know if I can send a file here. Wait, show you I'll send you a link from where you can get these images. or I'll just put it in the hackathon group. So you guys can just download it from there and test it out, or or you can just do it at the end. Yes. So use the name as input 1 for one of the image and input 2 as for the other image. I'll be forwarding it to the other groups too, just in case. Send it here. So I've sent the images. Suppose they're sending. Yeah, I've sent the images. You guys can just save these images in the same folder as you have the Python file in. Otherwise, you'll have to change the path, and you should name them as input 1 and input 2 respectively, or you can change the names again in the path. So yeah, that's for Bitwise and Bitwise are.
How do you upload the image to the VS Code?
It's the same. The code is like I have shown it to you, right? 1 second. So, like in the code, as you can see, you have that input img1 is equal to cv2 imread, right? So that will get your image into your Python file. If you are asking about how I showed the image there, that's basically you open a folder, like you in VS Code, you have an option to open an entire folder in VS Code. So when you and so on the left hand side, you will get this series, or you can get all the files that are part of the folder, and you just double click on them and just open it.
Okay, thanks.
Yeah. For the code part, you just need to open the file in VS Code that will run the thing. I just showed that so that everything is in like one location. So yeah. So back to the so we have finished bitwise operations now. Anybody else has any queries regarding anything we have done until now? Regarding issue or any images? And if you guys have run the code, just put a thumbs up. It'll probably take a while, so I'll just go on with the other topics. So yeah. So we have contours. So contours is a very important part of image processing. So it helps in like shape analysis and object detection. You would have probably heard this term contours in so many different if you have ever tried to dabble in image processing, you would have seen this word come up in like detecting or faces or objects or colors or images or anything and everything. So basically contours is like you draw a shape around what you want to detect. So like let's say it will draw a line along all those pixels that have the similar intensity. So this will help. So when you take an image or a face, for example, it would be drawing. It's like my face against a white wall, or our faces against a white wall. It is like an anomaly in the entire perspective that it's a white wall. So it's like you have something different there. So we will take all those pixels and consider it to be a separate thing. So then when you're doing like, let's say, face recognition, but you'll still have like faces and, let's say, towels or clothes on the white wall. You don't it'll consider all these as separate. So if you don't detect or try to recognize the difference, it will consider them all as, let's say, people, or all as towels. So these contoured images, you're going to apply these models, detection models or recognition models, to figure out if it's a face or a body, so, or a towel or whatnot. So this contours help in like uh, getting these separate objects or anomalies in the image out, to help you process them to figure out what they are exactly, and use them in your project or whatever it's that is you're trying to do. So this function, I will not really go in depth into it. So it will give you basically it's a two output. It gives you two return values. So one is called as contours, and the other is a hierarchy. So contours, as I just said, is it gives you those parts out. Each detected contour will be given as a set of vector points, which the code can understand as what it is. Hierarchy is basically which, when like, since, like I told, you can have multiple different contours or slash objects in the image. So this hierarchy will tell you, is it like is the person the first, like is the face, which object has been detected first. So if I have a face, a mask, and a bottle in the frame, and it detects all these three contours, it will tell the face, maybe the face will have the first number in the hierarchy, like the bottle will have hierarchy 2, and the name, mask will have hierarchy 3 or 0, 1, 2. So it'll help you in detecting. So when, if you want to like choose out each of these, it will help you in detect it. You can choose, you can take from this hierarchy, it'll be like an array from where you can call each of these contours. And mode is a contour retrieval thing. I don't think we really use it. Check it once again. Yeah. So yeah, we don't really need to use this. So, and then you have we pass in like, there are different functions called cv2 dot retree and chain approx simple, which we will be using later on. And it will help in approximations and to detect offsets, etc. So that's about contours in this. So yeah, basically contours help in detecting different anomalies, like in a white wall, it detects the images or objects present in it, which you can then process. So an area to is equal to CV to the contour area. It helps in finding the area of the contour. So let's say you are doing red color detection, and then but you will have very small dots of red that the codes will detect, which will kind of annoy you, because you will want only the biggest area available in the given frame. So that will help you in like, so this area will give you the area of the contour, so you can like use it to like filter out unnecessary informations. Okay, so once you have detected a contour, you need to find the bounding rectangle. So when you like, for example, I told about lane detection, right? So you will have to find out the contour in the image, and then you will have to draw a bounding rectangle around it to help you detect what is the like the coordinates of the center, or to check if it's detecting the right colors, the right lane, or is it like detecting too many small boxes, so that you can then slowly filter out, so that the code looks neat at the end. So the bounding rectangle function, it has only one parameter, that's the contour, and it returns four variables. So xy is the top left corner of your contour, and w and h gives the width and the height. X and y gives the bottom left point of your contour, and then w and h gives you the width and the height of the bounding rectangle that is drawn out on the contour. So it like, you will have a blob, it will draw a red whatever, it'll draw a box around it, which you can then depict later on using the rectangle function, and then you'll give you the coordinates of the box, of the bottom left of the box, and the width and the height. So using this information you can find out the center of the box, which you can then use to like detect the slope of the line and accordingly tell if it's turning left or if it's turning right and so on. So yeah, that's about all the stuff we'll be using. Any doubts regarding the contours and detecting the contours, area of the contours, and drawing bounding rectangles? Mm, I guess not. So I'll go on towards the project. So yeah, the project we are going to be doing today is to be detecting red color in our video feed. So I'll show how it works once so that you guys will know what this code is about. So check if it's okay. So yeah. Yeah. So I'll be sharing my entire screen now. I hope my entire screen is visible. So this is the code for the red color detection. So we'll be using all the functions that we have learned today, and yeah, some that we learned we probably wouldn't be using, like blurring, like we talked about it, and yeah, and I'll show how all these actually work. So as you can see, there's no red in the frame right now, and it's not detecting anything. So now if I press a show percent a red press bottle, it's detecting the red colors. So like now we can see detecting a lot of reds. I'll show how you could change that. So yeah, so first you import the necessary libraries, that is here Numpy and CV2. Yeah, I'll show you PPT itself, I guess.
What is the NP and NumPy as MP?
So like I said, right, NumPy is like a pretty big word, I guess. So when you keep using NumPy dot array, NumPy dot once, it's like kind of time consuming. So Python has this feature where you can rename libraries in your file to suit your needs. So it's a general consensus for people to use NumPy as NP so that you can just use np.1 np.array to like, it's easier to code and it's like a general thing, so people just end up using it. Yeah. So let's begin. So first, yeah, we have the basic thing, that is to import your libraries. So we're using NumPy as NP here and CV2 library. And then we capture the webcam video. I'm using my laptop webcam. So here's 0. For those who are using, let's say, an external webcam, they can use 1 instead of 0 there. So you guys can type this out in your code editors right now so that like you can see each thing one by one. So you can go through this fast. And so I hope everybody has written. So I'll go to the. So now we start the while loop. So we use an infinite while loop here. So that is just put while of 1 or true or whatever you prefer. And then we have underscore comma image frame is equals to webcam.read. So as we saw, webcam is the function into which we are getting this video feed into. So this webcam.read function will read the data from your webcam variable, and it will give you two return values. One will be your, like I said, to check if the webcam feed is actually true or not. And the other is your image frame. Image frame gives you the frame that in that while loop, that frame. So the underscore is, yeah, you can use if the underscore condition is true, then only the rest of the code to work. I'm not really doing that here, but for certain projects, people prefer to use it so that it works only if the feed is available. So, and then now we have to convert, since like I told, HSV is preferred in image processing because of the better, because of the different values that you get, like about the colors. Like BGR, RGB just gives you colors, but your HSV gives you colors and stuff like saturation and intensity of the brightness, so that you can use it, you can process the images better. So we create a HSV frame that will, since we will still have the image frame in the final depiction, so that you can still make it look nice. It still looks good, but also the processing is done better. So the HSV frame will be used for processing, and the image frame will be used for your depictions. So yeah, so we convert the image frame into HSV and pass it on to a HSV frame. So now we create the mask. So we create a red lower. We create an array of we in this array, in this np.array, this 136, 87, and 111 is the lower range of red that you want to use. So we'll create an array of low that gives the lower value of red that you want to put in the mask, and then this 180, 255, 255 is the like the higher upper red value, like the other reds or other shades of, like in between this, whatever shades of red you can found, you will all of them will be a part of your mask. So like as you can see here, we are using the HSV frame here to create the mask. So we pass the HSV frame, the red lower and the red upper. So it creates a mask in between, in this all the shades between this red lower and red upper, and then we create a kernel of to create for the dilation part. So once you create the red mask, you dilate it so that it kind of smooths out your entire mask. I'll run this much. I'll show how the mask works since somebody wanted to see that. Second. So I will just comment out the rest of it, and I'll pass here the red mask. Let's see what happens. So you can see there is no, like when I showed you my initial image, there was no red, right? So there's nothing to be shown, and there's like my mouth is considered a bit red. So now I brought the bottle into the frame. Now you can see the entire bottle is considered, it was white, since it's within our mask. It's a part of our mask because it's between the red ranges. But if I have nothing, I will have, since there's no red in my frame. Right now, this white dots you can see is due to my tongue and lips. It still considers those, but yeah, if you change the area of red color detection that you want to do, it will filter these out. So the person who wanted to see about mask,
Thank you.
hope you're happy. Yeah. So yeah, I think I'll show the rest here itself. Sorry. Okay, so next we detect the contours and hierarchy. So this cv2.red tree is supposed to give you the mode. So as I told about, one second, I'll tell you what mode is. Share the PPT again. So mode is basically is a contour retrieval method mode. So it's like how the contour is retrieved. Sometimes you get it in terms of bits and other such form. It's a bit in depth, so I don't think we'll go to those here. So, but what we would generally use is red tree for the mode, and we will for the method of approximation we use chain approximation simple. So it just approximates. So for what exactly is contour approximation? It uses some algorithms to help in reducing the vertexes. So like you show a bottle or you show a very obstruse image, it will give you a lot of like vertexes and unnecessary corners. So this approximation method helps you in reducing of those, so you get a more smoother image to view in. So the next part is our for loop. So enumeration function. So what an enumeration function does is, one second. So an enumeration function basically is a Python function. So it just runs through all the contours. Like I told about, you detect multiple contours, right? So it'll go through all these contours and it will pass for, and it'll give you two return variables. So one is will be something called pick, and I'll be the contour. So this contour is what will be then like. So now we are separating out like, since you have like some 8-10 contours in your frame, you will pass each contour into your and then process the each contours. So some contours will have your red colors, the others won't. So first we'll check the area of the contour. So here I've given this if condition of that size of the contour should be like it should be more than 300 pixels square, you can say. So otherwise, if so, then it will draw the bounding rectangle in others. If the area isn't, then it won't. We can also check maximum areas. So like you can pass this into an array and then it'll take the hugest red box only. But for that, you'll have to like do a bit more of coding. I'll just make convert like as you guys, I'll just run the code once more and show it. One second. Yeah. It's visible now. So here I've given 300, right? So I'll show you the problems with it. We can change the previous thing and make this back into image frame, right? So yeah, as you can see, my tongue and lips are still being detected as red because 300 is too small, and because of this there'll be multiple red boxes that you can see. So I will change this area to, let's say, 800. So then it still detects when it's very open, but as you can see, these are not detected. And then also the size that it detects here is much. The number of boxes that you can see has been reduced. Try to one hand see. So yeah, it detects a move. The size of the box it's detecting is more, so you get more accurate image. So yeah, these are like it's more of trial and error. There is no like surefire way of doing it. In just like 1200 now, as you can see, it's detecting the whole entire bottle as one single box. So this will give you like, it'll get me a more precise calculations. Otherwise those red boxes will give me like random coordinates, which it will not be it won't be useful. So we could make it like 500 to in order to get like perfect image. Let's see. So yeah, it's basically giving me almost one box. Yeah, it's giving me just two right now. So yeah, the finding the maximum area would be advantageous in these situations, but like sometimes you'll still need to just go with the smaller a sizes too. So it's more about your needs at this point. Last time to show much more it could change. It's basically just one box, right? Yeah, so you can see. So this is the for the boundary. So then it's the usual thing. I will so then we take the bounding rectangle. So this bounding rectangle, it draws the bound, it takes the bounding rectangle around the contour and gives me the coordinates. Now here is where you draw the I draw the rectangle here. So again, as you can see now here, I'm using image frame because that's what I want to show in my output, because that is what people recognize, the red, green, blue format. So it draws a rectangle in the image frame. So as you can see, the HSV frame, image frame, they are two different frames, but they are basically processed version of the image frame. So whatever coordinates you get in your HSV frame or in your grayscale format or whatever you're using, it can still be passed on to your image frame to be like the same coordinates will work there too. So it's just to do better processing. So here I pass the rectangle. So x comma y, which is the coordinates of my 1 point, and x plus w will give me the like x comma y here gives me the bottom right. So x plus w will give me the uh, right side one, like bottom like bottom right axis, and y plus h will give me the top right. Will give me the top axis. So like I'll run it and show you what exactly I mean. So so the top right corner you can see in this bottle will be the x plus w comma y plus h. So x comma y will be the bottom left corner of your box. So and then I've drawn with the red in color, and I've given a thickness of 2, and then I put the text as I told you before. X comma y will be the text location, and then I show the red color detector, which is the window name, and I've given. And so cv2.wait key, it basically gives a delay. So when I press this Q thing, like when I want to close my window, I wanted to have some sort of delay instead of just going to directly crash it. Since you're running through a while infinite loop, it can have some discrepancies here. So we just give a delay to just be sure. So it's just a very 10 millisecond delay, I assume. And then inside the if condition, and so 0xff just takes the keyboard input, and if it'll check if the ASCII value of q is and if ASCII value of q is, if this q button is key is pressed, it will, and so these two conditions satisfied, it goes into my if condition, and it releases my webcam feed that we have accessed in this video capture over here. And then it also destroys windows. So destroy all windows is basically closing that window that we created here. Is it image frame window that we created here? That window will be closed, and then break just leaves out of the loop. So let's see. So here I have done red color. So I will show for other colors too. So in other colors, you basically just change these array values here. So I don't really know the exact values, so I'll have to Google up the lower values. So these is the ranges people have defined here. So let's try this blue color out. I will not change variable names. I'll just pass the values here. So now I have given for blue, I assume the values are right. I won't change anything else. It'll be still said red, but I'm trying to do blue color here. So it's, yeah, I think the range values is low. I think this was yellow because it's detecting yellow color in the frames. So yeah, yeah, you have to be careful with these values. There is some codes online that help you in detecting the, like, it'll be a pointer function. So you press on a point, you can get the pixel values of that. So yeah, so this is basically for yellow, and yeah, so okay, there's more things here. I'll try this blue values, I guess. This works, it does, else. Yeah, so you can see it's detecting blue color. It's the SID card. So yeah, I'll show different types of blue color. Yeah, it's detecting dark blue, and yeah, it's detecting these shades or different shades of blue. So that's about our main part of this course. So I'll share the code again. So I'm sharing it for blue right now. So did anybody have any queries regarding any part in the code? Like why have we performed certain function, or like why is this in this order, anything? Or the mask, or you want to check how something works, like how does a mask look, or how does a contours look, anything?
I guess the whole code is not shared.
I've shared in chat. Oh, I'm sorry. It shared now, or I think it has a. Yeah, I'll send it in the group. Share the PPT for now. Yeah, thank you. So I've shared the codes on the group. You guys can try running it out. Also, we can detect multiple colors in the same image. So let's say I'll just copy this. I'm going back to the old red color. So yeah, like if I create another mask. So I create. Yeah, so this is for blue, right? This is also blue. So this will be for blue upper, and this will be for blue lower. And we create a blue mask for this. And then again, we do the same process. We dilate the mask. So this will be CV2 dot dilate of blue mask, comma, kernel. So this is dilated up your mask. So now we'll find the contours. So this will have to name it as contours underscore red. Then this will also then be contours underscore red. This variable is just in the for loop, so we can just use the same variable name again. So we use this again. So yeah, here I use contours underscore blue, and I can apply a blue mask this time. So,
Are you sharing your screen?
oh, I'm sorry. I've been sharing the window. Sorry again. I'm sharing screen now, right?
Yep.
All right. So basically, what I did till now, I created a blue lower, a blue upper, and a blue mask, and I dilated the blue mask. I renamed this for contours underscore red because we'll have to use, otherwise it'll have a naming issue. And now we will perform the same for loop through by enumerating through each contour in blue. Yeah. So so here I go through contours underscore blue, and you find the contour area, the same thing. We will change this to blue color. This- And this name will be given blue now, and this again blue. So now we will be doing the same. So now we'll be parallelly doing red color detection and blue color detection. I hope I made I hope I made all the necessary changes. So let's see what happens. Yeah, so it's detecting blue ink red. Okay, I think it has some issues. Just a second. Just share. One second. Alright, I think I found the error. So, this works. I'll share my screen again. Issues. Okay, I'll just show a code I've already written. That's it. Detects everything other than red as red, and red is not identified. I don't know how that has happened. One second, I'll respond to the message. Rectangle box is not on the red object. Is it possible for you to share your screen? This I just sent you the code that I am using on the meet. Oh, sorry, I'm muted. Okay. Yeah, you can install Raspberry Pi, but the thing is, Raspberry Pi, it depends on what you're using, but usually it's very slow. We had done one project once, and we ended up having to actually use the laptop and communicate with the Arduino. So then you will have to use OpenCV probably in C++. 1 second, Shaurya. So you probably have to use it with C++ or probably a more with less of the opportunity, like you gotta use OpenCV 2.7 or something. So yeah, those will be issues, but yeah, you could use it on a Raspberry Pi. If you have at least a 4 GB RAM, I assume you can use on a Raspberry Pi. Else it'll be the FPS, the frames per second will be very very slow. Yeah, Shaurya, if you want to share your screen, you can. Else, even a screenshot would do. Or no, just share your screen. Yeah, it'll be better.
Is it visible?
Yeah, visible. Can you like leave the frame and just show the red bottle only?